Cool.
Cool. So, sort of to continue on, this will be sort of just some general stuff and some mistakes that we know people do. Here's some of my pet peeves about the things I see people do that really annoys me. Please stop writing like using namespace STD or GLM, which we do in some of our labs. I think I've done this rant several times before. You know, you're just cluttering up the global namespace, and you will, or you might get, you know, compiler errors because you get ambiguities in your code. And what we've noticed often in Visual Studio is that it can really confuse the IntelliSense, so it will tell you that there's ambiguity with cout. Yes?
Can't you say for programs with just one file using it would be fine?
No. Like why?
You can get ambiguity just with one file as well.
Yeah. But the yeah, you can. Sorry, I don't think I heard your question properly.
For only one file.
Yeah, you can still get issues with ambiguity if yeah, because we got that with the first graders, that it really confused the IntelliSense, or you probably won't get compile errors because of ambiguity. But we have had instances where IntelliSense, especially on Visual Studio, got super confused because it sort of perceived it to be ambiguity there, and like had red lines on their code that was completely valid, and like the code still compiled, but the IntelliSense told you that there was something wrong. And in general, like, I want to know where stuff comes from when I read code, and I sort of find it hilarious that in a lot of other languages, like in C#, etc., you have all these namespace solutions, and they don't have includes in those languages, but the first thing that they do is that they go to the sort of top of the file and write using, and then sort of eliminate all the namespace organizations that they just, you know, created for themselves to introduce something that looks like includes. So anyway, just stop. Like, you can do it scoped, but don't do it unscoped, and at least don't do it like in header files, because if you do it in header files, then everyone that includes that header file will also get sort of that using namespace. And if I then suddenly include your header file, you know, before another header file which like uses another namespace or doesn't use this or has some sort of other stuff set up, you can quickly get into weird errors because they're making different assumptions. Like, it's, yeah, just don't. You're stopping yourself from having to write 5 more characters, but those 5 more characters, or at least in the terms of the standard library, tell everyone sort of so much more. Yeah. So the other part is, you know, avoid raw pointers, prefer references and stack allocated objects. This is sort of the modern C++ take on this. You know, if you use vector or stuff like that, then they will allocate memory for you, and they will free that memory for you later. Instead of owning raw pointers, you can use you know, unique pointer. However, OpenGL is a C sort of a C library, or not a C library, but it has a sort of C specification, I guess. So, you know, you will send raw pointers, etc., to them anyway. You will be interacting with that stuff. But in general, like, if a function takes you know, a string or something, send that string as a reference rather than as a pointer, if you can. Yeah, CPP reference, I already showed it off. It's a cool, it's a great resource, but it can be a bit hard to read, especially in the start. So, you know, use the tools available to you so that you can focus on graphics, not the other stuff. That's sort of the general. Is there any questions? No? Cool. Nothing controversial? No? Cool. So then, here's some typical mistakes that we see, that we've seen earlier, especially if people go and make. So you're now going to, you know, be working with OpenGL code, and you've all had object-oriented programming. So you might want to think, hey, let's, you know, wrap all of our shaders into shader objects or something, and create a really object-oriented system. You're free to do that. However, be aware that there are some sort of interesting situations that can happen if you don't do this properly. And one of them is that the structure might sort of, so this isn't an OpenGL sort of example, but it shows up, it sort of shows what can happen. So here we're creating a string class, a super basic one, where this is the ones that you've probably seen already. You have a character pointer to a string, and then in the constructor you create a new character buffer, and then you copy into it some real fancy string, and then at the end you delete the string, which is that way, I think, right? It's been a while. And then you delete it. Because as we've learned, every time you say new, you have to say delete. However, in C++, there's this cool thing called a copy constructor, which you've also learned from Frode. No? Okay, so it's basically a way to copy your objects. And this copy constructor gets sort of, it's a sort of hidden function that just shows up. And this is sort of where you can mess a bit over, because if I don't remember wrong, it essentially just sort of raw copies your entire object. So it's like if okay, so let's just jump out to the example. Say here I create my string. Yeah. So here I create my string. And then I create a second one. And then I call the copy constructor by sending the first one in. So what the copy constructor will do, it will just sort of member-wise copy each member of the parameter that comes in. So it will essentially look like this. So I send in the other string, and then once we get in, we say that my string pointer points to the same character array as that other string. Right? Everyone's with me so far? And that's cool. And then we also have the sort of copy assignment operator, which essentially just does the same job. This is what allows you to say that A is equal to B, and then get the assignment. However, there is a problem here, which is that these two objects are now pointing to the same character array, and when we get to this line, when we get to this line, 141, the curly bracket, the second string will die. And you've all learned about destructors, right? So it will then run its destructor and delete the string. That's what it's supposed to do. The sort of problem here is that when we then try to print out our sort of original string that still exists out here, that memory will have been deleted by the first one, since they're sort of pointing to the same object. So sort of a way to show this is that if we here just comment out the delete, so what we'll do is that instead of deleting the string, we'll just write the string was deleted to it instead, and run this. It will say string was deleted. Does anyone see that as an issue? So, yeah, everyone sort of gets why that's a problem? Yes. Cool. Yeah, so, that's a thing that we often see happening. When people start wrapping their GL stuff into objects, is that they don't think about that. And there's different solutions to dealing with this. One solution is that you could have, instead of using your constructors, you can have like init functions. So you can have a init. This is like, don't do this with strings, but for OpenGL stuff, that's pretty okay. So you can have like .init and .destroy functions to like say, now I'm creating this, and then now I'm destroying it. Then you don't have to care about the copy constructors, etc. So That's one way to solve it. Another one is to use unique pointers for stuff. So unique pointer is came in C++11, and it's basically a pointer that only, unless you go around it, that is sort of owned, or it's owned by one particular object. So you have a pointer that other people can point to, but it's clearly defined when that life cycle or when that sort of pointer ends, and that's when that unique pointer goes out of scope. Or you can do something called move constructors, which I won't show, but it's essentially a way to say that you can't take a copy of something, or like I might as well just show it. So it's a move constructor is essentially that instead of taking a constant reference to the other string, we take a double ref, and then we say that the our string is equal to the other string, and then the other string is equal to no pointer. So that when we're then sort of doing our moves, which when we're then doing our moves, instead of sort of creating or copying or something, we're sort of clearly defining that only one object can own this resource at a time, and then we sort of null it on the other side, so that we don't get an issue about destroying objects that aren't owned or that are owned by someone else. So that's one way of dealing with that. We also see a lot of errors with people doing size of. So since OpenGL takes a lot of void pointers, they need to know the total size of objects in bytes, and a lot of the mistakes we see people do there is that they take, because if you take the size of an array, then you'll get the total size. But if you take the size of a pointer, then the size of a pointer is 4 or 8 bytes. No matter how many variables it is inside the array that it's pointed to. So, for instance, if you do GL buffer data, I think, which takes in some parameters, but at some point you're supposed to give it the actual data. So we'll just say GL, which is 0. Yeah, something like that. So we're just creating one point, and then we'll send in the data, and we'll send in the size of the data, which, since this is an array, that's totally fine. However, if we instead do this, so it's a pointer that points to the data, and then we do pointer, then this is a problem. Because this pointer has a specified size, which is 4 or 8 bytes, depending on your architecture. And there's no way for the pointer to know how many elements it's pointing to, if it's pointing to an array or whatever. So in this case, you will also have to sort of multiply with the number of variables, which is 3. This is also something you need to take into consideration if you're using vectors. So if you're doing this with float, and then which, let's say this one contains actual data, then we can say vec data dot data. So if you're using a standard vector, then dot data is the way to get the underlying pointer to it, like C-style pointer. So it's a way to interact with C-style interfaces. And then if we do this, then we're still sort of, this won't work either, because this will take sort of the size of the vector, not the number of elements it holds. So you'll have to go vec data dot, or we can either do size of float multiplied by vec data dot size, or I also see a lot of people write sort of vec data 0, which you should be a bit careful about, because if there's not actually any elements in there, then you've done good. But yeah, so that's sort of that's typical mistakes we see. Some other mistakes you see is you'll probably using uniforms, and to do those you'll be using functions, and the API that OpenGL uses isn't always as sort of easy to look at. So they have a lot of stuff where you have like uniform 3f, and then you also have another function called uniform 3fv, which is like free vector or float vector, I think, or something. Which that's fine. It's just so for one example, me and a friend when I did the graphics course, we were sitting a couple of days before the exam writing up a sort of framework for the exam because they can still use frameworks.
Yes.
On the exam, yeah. We could have this. Well, I gave you the option to say no.
Yeah, probably. Yeah. No.
And we were sort of writing up a framework before the exam, and suddenly everything went black on my friend's computer, and we were like, okay, what's going on? And we used a lot of time trying to debug it, and in the end we just went like, let's just go through line by line because we have the same code. And wouldn't you know, once we got to like file number 7, line 37 or something, he had written uniform 3f, whilst I had written uniform 3fv. So we just added a v to his function call, and suddenly everything worked, like perfect. So be careful of that. It's like, be careful about, for instance, you have autocomplete and assuming that actually autocompletes the 100% correct thing for you, because it might not. Yeah, and this one is actually new, and so it wasn't there last year, but I've seen it before, because a lot of people have started using vectors, which is a great thing. However, a common mistake that we then see is that people start creating pointers into the elements in that vector, which is quite problematic, because the way the vector works is that it will sort of allocate a specific size or a certain amount of a certain section of memory, which is usually more than you actually need. So like if you say that you need 2 elements, it will like allocate 4. The reason it does that is that each time you do a pushback, so append to the back of the array, it will reallocate if it needs to. But reallocating the entire buffer is an expensive operation. So they're allocating more than they need, usually double, just to ensure that they're not sort of moving more than they need to. What can happen is that if you start pointing into that vector, and with like a pointer, and that vector gets reallocated, no one will go and update your pointer to sort of point to the correct place anymore. So you're now suddenly pointing into a piece of memory that you have no idea what's actually in there. And since vectors reallocate sort of, on a semi-random basis, or not random, but you can't really see it from the outside when they're allocating, that pointer might not actually become a problem before like 5 minutes after you first assigned it, because that's when the vector reallocated because you did another pushback. And tracking down those errors are in general quite hard. So, don't try to avoid pointing into your vectors if you can. If you can guarantee that its size will never change, fine.
What's the alternative pathway? What would be an alternative?
Was that your question as well? Or?
Yeah, basically. Also at that point, why wouldn't you just use an array?
If it's constant? Yeah, then you can just use an array.
Yeah. But what is the alternative?
The alternative is just store indices. Like the index. So, if you're going to point at the thing at position 5, just store 5 instead and do the lookup later. Yeah. Cool. Indices in general are super powerful. It's like I would actually consider them more powerful than pointers in some sense when it comes to vectors, because they don't get invalidated. Right, so some general tips now that you're starting to do OpenGL. So you've probably already seen this, but your background should be a unique color. Don't set your background to be black. In our experience, that's usually because if you have, for instance, a bug in your fragment shader, so the one that does coloring, you'll just get a black color. And sort of spotting a black cube on a black background isn't really easy. But if you can see that, you know, hey, I have the correct mesh, it's just that it's black. And I can see that because I have a sort of gray background, then at least you know that the problem is, you know, not in the vertex shader, it's probably in the fragment shader or something. So, you know, set it to gray or blue or pink or whatever, just not black. Also use the GL get error function for error handling, at least for the moment. We are looking sort of into alternatives for that, but that's the one that's fully compatible. I'm saying here that you should use this together with the toString function. We are sort of supplying that through the GFX library, which I will introduce tomorrow. At least we're supplying parts of it. I think we're supplying all the errors. Yeah. Another thing I talked about here that, you know, you can make shader objects, etc. One thing I've found is that instead of creating sort of shader objects and trying to figure out how they all interact, just create yourself a render interface or something and put everything behind there. So, you know, I want to create a mesh. That means I go to sort of the render interface and I say that, hey, I want to create a mesh, and then I get an ID back. And then if I want to draw said mesh, I just say to the renderer, hey, draw this mesh that's identified by this number or this name, like something. Because that means that, you know, you have a single place where you're reusing a lot of your resources, and hopefully you can also create an API that's relatively reasonable to work with. Try to avoid spreading your OpenGL code all around your logic. That quickly gets messy when you're when you have a lot of stuff going on. So yeah, GPU debugging in general, I consider that to be relatively hard. So, you know, ensure that your CPU code is actually correct first. Then sort of look at the GPU code. Cool. And then for the last one, which is like, this was mostly my talk from last year, and I also noticed that I wasn't sort of as, what should I say, as pushy this year about the sort of modern stuff. That's also because I've changed my opinion a bit. You know, you will be working a lot in groups for this course, and you should sort of be pragmatic about the different features that you actually use. So, you know, don't use the modern features unless you actually benefit from them. Don't overcomplicate your problem because you want to use a standard algorithm or a specific standard container. You know, it's important that everyone on your team understands the code you write. This sort of applies both to template metaprogramming and like bit flip hacking, like low-level stuff. You know, iterate on your code. Try to hard code it first and then parameterize, or if it needs to be parameterized or abstracted, you know, solve your actual problem, not the one that you imagine that you're having. And then if you want to look at sort of like patterns, etc., ensure that it's actually worth it to add the initial complexity that a pattern might introduce. Like I did when we did our Pac-Man game for our hand-in. I went like super nuts and did a whole component system with like super many interfaces, and it was really nice built. Like you could probably generate a super nice looking UML diagram of it. Looking back at it now, I have no clue what's going on, because like it's just everything is spread out and it's way more complicated than it needs to be. And yeah, so you know, be aware of that stuff. Nothing comes for free. And also don't assume that third-party libraries always solves your problem better than you would. It's sort of a balance, really. In terms of resources that I can recommend, look at the talk Modern C++, What You Need to Know. It's brings up essentially what I've done now and some other stuff. You know, data-oriented design in C++ for, again, the other side of the debate. Yeah, so it's especially watch the one that's called Curiously Recurring C++ Bugs at Facebook, and see how many you can spot before he actually says what the bug is or what's the problem. Me and a couple of friends went through it, and it's really enlightening, and it's weird. So watch that is that one. In terms of books, Game Programming Patterns could be really cool for people to read. It's online for free. So, you know, if you just go Game Programming Patterns and go to that, then you can read the entire book for free online. And it has a lot of stuff you can look into, like flyweight and components, event queues, etc. Again, back to what I said, that ensure that, you know, your problem actually needs these solutions before you apply them. But it could be interesting to like look at them and see what's there, test them out. Yeah, and then there's a book called The Tour C++, which is also quite good, written by Brown. Cool. Any questions?
Will these slides be out on YouTube?
Sure. Yeah.
You'll be talking more about programming patterns eventually, right? Is that the plan or not?
Sure.
Right. So if we are getting a bit of background, I think some of you may have been or may have gotten lost a bit when Per-Morten was talking about uniforms and, you know, meshes and some of the 3D concepts already. So that's something basically that we probably should revisit in the graphics debugging session, but then at least know already what to look out for. And it's particular, for example, using code completion is like a classic of getting the, you know, uniform specification wrong. So, but that's something you can keep an eye on already, even though we haven't started really yet. But some of the other things, it probably doesn't hurt looking at the slides again once you are a bit more entrenched in OpenGL in the next week or the following week. That's,
I mean, we still have some time left, so I can probably jump into the asserts stuff.
Oh yeah, sure. Go
so
for it.
have to use time
So no more questions. Any other questions right now?
Anything.
As far as those general issues with C++ are concerned.
There's one thing. When you talk about copying an object, there are like two things pointing to the same data. Why wouldn't you just create an object and just copy the values and then make them point to it? So.
Well, that's one way to do it. That's deep copying. The point wasn't sort of what you should do. The point was to sort of watch out for what code gets generated for you, because that like now I wrote the copy constructor, but that copy, like if you don't write it yourself, the compiler will give it to you, and it might be that the compiler gives you the wrong.
Oh yes, it's more like how the library might work.
Well, not the library, the language in that case, but yeah, it's sort of like how someone might pull the reg out beneath you without you sort of being aware of it. And we've actually seen some cool mistakes related to that. So I think the favorite one I've seen is, so a friend of mine he started using the for auto loops, but he forgot to take a reference or anything. And he did the sort of init and delete aspect, but he had defined a copy constructor, but he had not defined a destructor for his class, for his like vertex, like mesh class. But he had defined a copy constructor that would sort of create a new mesh for him on the GPU, and he forgot to write sort of the reference sign when he did the iterated over all these elements, so they would create copies for him instead of, you know, instead of taking reference. And what happened then was that each time he went through a for loop, he would create a copy of the mesh, sort of all the meshes in the container that he was iterating over. So, you know, when you started that up in Visual Studio, you have this like little memory tracker on the side that was just growing linearly from his program started, and it never stopped.
on that note, we probably when we talk about graphics debugging, we need to use the memory monitor, right, quite explicitly, because we had it last year as well that we didn't pay attention to it in graphics, but actually it's a good indicator that you're probably doing something wrong, right?
Yeah.
So in terms of copying stuff instead of reusing, yeah.
Like, this is where it's sort of like you can get into where C++, if you forget some, like, so having the range-based for loop is really cool, but it's sort of like you can get into the problem where if you don't do a reference or forget a keyword or something, then it might not do what you're expecting, but it will look that way. And that's, you know, the least fun problems to have is when something looks to be working correctly, but behind the scenes it's not. Because then you'll, like, the guy who did all the copying and created the memory leak, so the teaching assistant who was correcting this didn't have any issues at all. Or other than that, he saw that the memory was rising linearly. However, my friend was running on sort of like a really super old computer, and he would actually like crash after 2 minutes, because then he ran out of memory. So it's yeah.
Just a clarification, so the copy constructor always makes a deep copy, right? So all nested objects are copied as well, or not?
No.
No.
That's the problem.
Right.
The one that's auto-generated for you doesn't do.
Okay.
Copy.
Okay.
Or
right.
if you're doing if you take it sort of does whatever the copy constructors of the memory or of the member objects does.
Yeah. Okay.
So if I just have a pointer, then it just copies the pointer. But if you have a vector as a member variable or a string, then it will invoke the copy constructor of the vector,
cool.
which will do the deep copy for you. So if you're using sort of a lot of the modern standard stuff, or just standard stuff in general, then it will do the correct thing. However, if you're creating a shader program, that's OpenGL specific, and that's just an int. So it will just sort of copy the int for you. It won't generate the correct copy constructor.
Cool.
Cool.
Asserts?
Sure.
Brief bit, that's 20 minutes-ish.
Right, so we're going to hand out a library for you to use, which is sort of to try and help you guys a bit. It's called, we reserve the namespace GFX because we can do that, so none of you can have the namespace GFX, it's ours. And with that, we're adding a bunch of functionality, so both for helping you with graphical debugging when we get to that part, and with sort of general debugging. And one of the things that we're giving you is a logging system. It's a pretty basic one, but it should get work done so that you don't have to use cout all the time. So it's essentially the way it works like printf. Anyone here has done printf before? Okay, one hasn't done printf before. So the way this works is you guys have learned cout from Fuda. I don't like cout, and I know a lot of other people don't like cout, and I don't really know about any other programming languages that uses that type of stream-based output. So what we're doing is that we're giving you the C-style version, which is the better one. So we're supplying you a bunch of macros to help you do debug information. They take printf style arguments, and essentially what that means is that I can write here is debug message like that, and then I'll probably get to the terminal where I actually cool. And then you can see in the back here that here is debug message. And the reason that we want you to sort of use that those logging systems instead of just cout, if you write your own, then please do, is that we'll give you a bunch of extra information. So, here we're not only just printing out the debug message that people wrote, we're also printing out, what's the category? Is this a debug message, or is it an error, or is it a warning, etc. And we're saying which file that message came from, and which function it came from, and what line number in the file that came from. So we're sort of trying to give you as much information as possible to help you, because logging can quickly get messy, and hopefully this will make it a bit easier. So So if you want to, you have to sort of supply the format yourself. So what you essentially do is that, you know, if you want to append a string, you can say, sorry, percentage s, yeah. And you know, here is a string or something. So if we then run this, and I gotta figure out where my terminal is there. You know, it will say, here is a string. To put out integers, then you do, you know, percentage %d, and then supply the integer, so 2. Then you'll get, you know, 2. There's a on CPP reference if you go to printf. You can see here that there is a whole table, or here's like, you know, a whole instruction manual of how stuff gets formatted, and a whole table of what sort of letters means what. We're not asking you to memorize this. No one actually memorizes this. I look it up all the time. It's just, you know, that's how we figured it was easiest to write it, is using the printf style. One thing to note is that if you say percentage %s, don't send strings in here. Like, you can't do, you know, this. That won't actually work. Or it might work for a while, but usually it doesn't. Because since this is a C-style interface, there's no standard strings. So what you're doing is that you say .c string instead, which will give you the C-style string that you can send to the macro. So we have 4 different categories of this. We have, you know, debug, which is meant for debug messages, info, warn, all have different colors. And lastly, error. The difference between error and the other one is that if you actually log an error, we also terminate the application. Which is essentially write this if you're like in such a mess that there's no way of recovering. That's when you log an error, and we log that for you, and then we just terminate the entire application. So you can use those if you want. And the reason I'm mentioning those is because we have this beautiful thing that we're also giving to you, which is called asserts. Let's see, where we actually have it. So, what the heck did I do? Cool. Yeah. So this file is already out on the GitLab page. It's expected that you read the documentation. I expect it. I know many of you won't, but I still expect that you do. So, you know, if you do something that I've written in the documentation that you shouldn't do, then I'll say you should have read the documentation.
In my question, say I tried reading the documentation but still confused.
That's okay. That's valid. But if I say like, hey, don't send a null pointer into this function, and you send a null pointer into the function, that's not my fault.
In fact, if there's issues with the documentation, I mean, if it's really your understanding, then you should really ask, you know, what does it do? If you think the documentation is wrong, you can send a pull request, right? So, I mean, then Per-Morten can address this, and so that is, you know, work in progress anyway, right? So you guys are the beta testers. So treat it as such.
But yeah, as I write here in the documentation, that asserts are landmines or landmines that you place for yourself to avoid making mistakes. And they are. It's asserts are really great. So what an assert essentially is let's say I have a function, or hell, let's take one of the functions I have here. Let's assume that you guys don't read the documentation, because if you go down into this part here, not that part, this part. Does anyone see any problem with this code, with this function? Like just this part. Yes.
It could be no.
It could be no. You know, I don't actually have any checks for that. I don't want to do any checks for that, because I don't want you to I don't want the people who read the documentation and see that they're not supposed to send a null to sort of pay for the check of having to check if they follow the documentation. But I still don't want you guys to just get random results if you actually send a null here. So what we can do then is that we can do an assert, where we say, let's see, label should not be equal to null pointer, and then yeah, label is null pointer. So essentially, what this assert will do is that it will run the expression inside, so you sort of give it an if statement, and then if it doesn't, if the if statement fails, so you sent in a null pointer, then we terminate the application and we give the same information as previously, like where did the assert go wrong and what went wrong. So if we now call that function introspect vertex array, let me just move that. This is my beautiful test code for those who are sort of interested. And then we send in null pointer and call it, then hopefully, yeah. So now you see here that we get an error from gfx.h with like introspect vertex array at line 774. Assertion failure, label is not equal to null pointer, label is null pointer. And seeing as you guys are supposed to work a lot in groups, if you write an interface that has any like restrictions on what you're supposed to send in, like if you write a square root function, or write a function that uses a square root, and you take an integer into that function, then assert that that integer isn't, a negative number. And then, because then if someone, because obviously you wouldn't do that mistake of sending wrong input to your own function, so when someone else comes and sends the wrong input to your function, then they will the program will crash and they will be told that they messed up. So you place them for yourself. You place them for others, but also mostly for yourself, because you will at one point start messing up your own code. And that stuff really helps with debugging. And the cool thing about this is that I don't think we're doing it here. Let's see. Yeah, we are actually doing it here. So the cool thing about that is that on why we're using the asserts is that you have the option to turn them off. So you usually do this in code sort of everywhere. I know at least a bunch of game studios does this, or like everyone sort of works with asserts. And what you'll do then is that you assert stuff in sort of debug builds or internal builds. But no checks comes without sort of overhead. So what you'll do is that you'll turn them off when you're finished with the product, or you'll keep some on and turn some off when you're finished with the project, so that you don't have to pay for that check anymore. So what we could have done here is that we would just define gfx assert off, and then it would just be turned into sort of no code at all. So, yeah. Any questions about that?
Makes sense or not? Or any questions regarding this? I mean, right now it's super generic, right? You can use it for any C++ code right now. So it's actually a sensible, tool to perhaps even try out already, right? Even though we haven't dug into OpenGL at this stage. This stuff, however, becomes probably a bit more OpenGL specific.
Yeah.
I think we'll touch on that later, right? So that's so there is some. Sorry?
Whom use the IMUing?
Well, that ultimately yes, right? So Per-Morten will share more, but it probably makes more sense to talk about it when you guys had some initial exposure to OpenGL. to see the problems and where suddenly debugging makes sense, you know. So those is really about building up towards making your life easier, because one of the graphics thing is it's really hard to get something going in the first place, and it's even harder to figure out why it doesn't go, right? So so this tool will hopefully make your life a lot easier there. Both in terms of C++, so CPU, as well as OpenGL, meaning on the GPU.
Yeah, so the debug stuff, the logging stuff, you can use that straight away. So you can already just take this file and include it in your project. There is a sort of explanation to how you include it at the top of the file, because you have to sort of include it in a special manner. We can actually just, so since we have time, we might as well just show that. To include this file, what you do is that you can include it everywhere, because this is a header-only sort of, we're trying to expose it as a header-only library, because we don't want to inline everything or include unnecessary files that you aren't going to use. So what we're doing is that we're essentially providing all the functions, or we're sort of splitting the file in two, a header section and a sort of a CPP section. So what we're doing is that you include the GFX file, .h. You can include that everywhere, like include that everywhere you're supposed to use it. However, in one of the files for your project, just one, so for instance, main.cpp, you write GFX, hashtag define GFX implementation before you include the file. But only do that in one file. It also says at the top here of at the top here, like, you know, include it, do this in one CPP file, write GFX, define GFX implementation before including the H file, because you will run into errors if you don't do it, or if you do it in more than one file. Cool. But with that, you can use the asserts, and you can use the asserts, you can use the logging, you can use the enum string, which I'm still working on getting in all the enums. It's sort of an ad hoc basis on when I need the different enums. That's when they go into the sort of string to enum. But yeah, but the part here that's called introspection, that's really under active development. So you can turn that on, but that requires, that is the part that we get more into once we get further along the course. If you spot any mistakes in the file, just, you know, post an issue on it on the GitLab. Yeah. Any questions? Also, I break all the rules that I told you about in this file. So I do like old C-style casts, and I do a lot of character pointers, and a lot of non-templated pointer magic, and sort of like old macro stuff. That's, I don't really have any reason for that other than I found it to be more readable. You know, it depends. But then at least you're aware.
Cool. No questions? No? If you ask questions, you can also ask them, of course, tomorrow still, right? So it's no harm.
So tomorrow is debugging with
C++?
Yeah.
Visual Studio? Yeah, that'd be cool. Yeah.
Yeah.
So anyone who is not exposed or wants to a refresher on that one, but has had experience, it's probably worthwhile coming, right? Just to see how you do effective debugging in Visual Studio. This stuff may not be obviously useful right now because you may be used to different kind of programs you're writing, but in graphics, it is really useful to know a lot about debugging early and about you know, how to find your errors, because you will have them all across, and it really will make your life hard if you need to think about dealing with CPU and GPU code and so on. But nevertheless, everything being written only in Visual Studio, so it's kind of a
But it won't be, although we will be doing it in Visual Studio, it's semi-Visual Studio specific. Like you can do so. It will most of the like it's just breakpoints, so it's not that hard.
Yeah.
But the interface might look a bit different in other editors. But you can also do it in Visual Code. I assume that you can do it in the Mac, the Mac editors. Like if you have an IDE, you also have breakpoints.
Yeah.
So also, if anyone has any good bugs that they know about that we can sort of try to debug, then that would be really cool to have some like real life examples, because it's not that easy to come up with all of them. Also, I told you that if you look at the GFX code and you find bugs in it, report it. Don't do that until after tomorrow, because there may or may not be some examples of bugs that we could debug within the GFX edit.
Cool. Thank you much.